The debounce time operator lets you emit the last emitted value from the source observable after a time that you specify has passed between emitted values. Debounce time is useful in scenarios where there is a load of emitted values, but you are really only concerned about the last value after a pause in action. Two prime examples of this are saving user input from text box or a document after a pause, like Google Docs, or making a request for data after a specified time, like a search type ahead. Let's actually rewind the first diagram and add some time markers to make this behavior more clear. For every item emitted from the source observable, debounce time starts a timer. Then, if the time you specified has passed before another item is emitted, the latest emitted value from the source is emitted. Values that came before it that did not satisfy the time requirement are ignored. Let's start with a basic mouse click example to see this behavior in practice. Since we'll be creating a stream from an event, we'll import the from_event creation operator. Let's also go ahead and import the debounce time operator from args.js/operators. Next, let's create a variable called click to hold our click stream using from_event with the document as the target, emitting every click event. Now that we have a click stream, what we want is to only emit a click if a certain amount of time has passed between the last click. With debounce time, you're generally looking for breaks in user action to perform more expensive operations that only care about the latest value, like saving a user's text input. Let's call a pipe method on the click observable and add the debounce time operator. Debounce time takes a number in milliseconds, which is the time to make sure another emission from the source doesn't occur before emitting the latest value. For this example, let's make this an even 1 second. Now let's subscribe to this observable and log the emitted events to the console. When we save and start clicking on the document, we'll see that nothing is emitted until there's at least a 1 second pause between clicks. And then we have a mouse event. And we do it again, and then we pause, we have another mouse event. So debounce time is ignoring all clicks that occurred except the latest before the 1 second pause. Now let's take a look at a more real-world example using a stream of key-up events from a text input. Let's start by adding an input element to our document. And we'll give it an ID of text input. Now let's create a variable called inputBox to hold a reference to the text input we just added. So we'll call document.getElementById and pass the text input ID. We now need to create a stream of events from the input box. Let's call this constant input, and we will be listening for key-up events from the input box. All that's left is to swap out the click stream with the input stream, and let's save. Now when we type into the input box and pause, we can see the keyboard event emitted. This happens between each 1 second pause after typing. While this is nice, it would be more useful if instead of emitting the keyboard event, the stream instead emitted the value of the input box. To do this, we could use the map operator, but instead, let's actually use pluck this time. Let's go ahead and add the import now. And now we can add pluck underneath our debounce time operator, as we only care about the text of the latest events emitted after the debounce. Remember, pluck can accept multiple values separated by a comma to grab nested properties from an object. So, in this case, we want to grab the target, which is the input box, and the value property from that input box. After a 1 second pause in typing, the keyboard event will be emitted and transformed into a stream of input values, which is then logged to the console. So there's actually one small remaining issue here. If we type the same value twice in a row, it is still emitted. While this probably wouldn't break any of our functionality, it's likely we would end up doing unneeded work by issuing a request or similar when the value hasn't actually changed. To remedy this, we can use the distinct until changed operator we learned about to only emit unique values based on a comparison to the last emitted value. Let's go ahead and add distinct until changed to our operator imports now. And we can include it after pluck to compare the current text string to the previously emitted string, ignoring identical values. When we save, we can see that writing the same text twice in a row now ignores the second string as it did not change based on the previous emission. The last thing I want to point out is debounce time, like other rate limiting operators, also has a version that accepts a function, returning an observable which determines the timing for when to emit a value based on either an emission from that observable or completion. This could be useful if you want to dynamically configure your debounce duration based on emissions from the source. In practice, I find myself using the debounce time version much more, but let's check out debounce to see how it compares. Let's go ahead and add debounce now to our operator imports. And let's do a little reformatting to make this more clear. Next, let's replace debounce time with debounce. To provide the same functionality, let's import the interval creation operator to emit a value after a specified duration. Now, instead of simply supplying a duration, we will supply a function which returns an interval observable that emits after 1 second. While this actually mimics the functionality we had before, if you did need to update your debounce based on some variable or source emission, you would have the opportunity to do so here. When we save, we can see the behavior is exactly the same as before, emitting the value we type after a 1 second pause. To recap, debounce time emits a value only after a supplied duration has passed between emissions of the source observable. This can be useful for limiting emitted items when you only require the latest value after some period of inaction.